visible in Milky Way. Nakita Milky Way.
Wala na pagbaba. Mamaya pag-travel natin.
Nakita Milky Way. Yung Milky Way. Tapos hindi visible dito. Kasi nga may light pollution.
Baka ako naka-jacket.
Closer to me over here. Unfortunately, I'm going to red light sports ball. Well, I do, but it's my bag. I pulled out a juggling ball instead, which is a little weird. and no use. So, what we're going to do now is I'm just giving the telescope operators time to make sure that their telescopes are still pointing at exactly what they're supposed to be pointing at. And while they're doing that, I'll just finish quickly to the night sky. So, we have a reasonably clear sky in front of us at the moment. A little bit of a light cloud over to the east, over back behind us, and you can see it's a bit lighter over there where the sun has set. So looking up in the night sky tonight, a couple of really obvious things. We have some nice bright points up here. That's Jupiter, the brightest one. There you go, behind it is Saturn. They're planets. One of the things about planets when you look at the night skies, if you look over here at these stars, they're twinkling. Nice twinkling things. Planets, because they're not the faint little point sources of light, and they don't get as the light big chance it's a planet. The other thing we can see with the planets is that they go around slide. So if we continue that line all the way over here, so it's another planet. It's a nice orangey red colour. Mars. So they're going to be a bit between Saturn to begin with, and then we'll have Mars a little later as well. We'll also take a look at Nebula, where stars are born. We'll look at a Globular Cluster, where stars are kind of very time-doing for stars. And we'll also look at a galaxy far, far away. Well, it's not that far. It's far away by human terms, but not so much by stellar terms. So, you're going to hear some things tonight about distance. When we talk in distance in terms of stars and so forth, we talk in terms of in terms of things like light years. So, light year is the distance that light will travel in a vacuum in a year. It's quite big in human terms. So, light takes about 1.3 seconds to get here from our moon. So when you're looking at the moon, you're looking 1.3 seconds into the past. The light from our sun takes 8 minutes to get here. So if our sun was to suddenly disappear one day, we would know about it 8 minutes later. It's not going to, just in case anyone's worried. Like 4.5 billion years to go, easy. And it's going to be at least 2 billion years before it fries us all to death. We're good. So, don't feel like you have to rush those plans you have. So, light takes 8 minutes to get here from the sun. Something like Jupiter up there, about 40 minutes or so. Mars, I think it's about 16 minutes. 15 minutes, not that far away. The nearest star to us, the nearest neighbouring star to us, and we can't see it tonight because it is down somewhere around about here. The nearest neighbouring star to us, which is called Proxima Centauri, and we'll talk about that a little bit during when we switch up later, about 4.2 light years away. So the light has taken 4.2 years to get here, which means you're looking 4.2 years into the past. That is our nearest neighbouring star. Now, if we could travel at the speed of light, it would take 4.2 years to get there. We can't travel at the speed of light, we'd die. Also, we don't have the ability to do that yet. At current spacecraft speed of travel, about 20,000 to 100,000 years. So, your next holiday, probably not there. That's to give you an idea of scale of the things you're going to be looking at. You're going to be looking outside our galaxy at something that's 160,000 light years away. So you're going to be looking at 160,000 years into the past when you look at that. You're also going to be looking at a galaxy which gets into the order of millions of light years away. So you're going to be Joe will tell it better and there will be jokes. The rest of him for the jokes. Also asking questions. Are you ready to go, Joe?
Yes.
Lexi! Ronnie, you good? Morris, you good?
All good.
Alright, so here's what we'll do. Alpha group. You're in this dome here to begin with. So alpha group, you head off there with Morris. Beta group. Beta group, if you head into this building here with Lexi. Let me see who that has left. Gamma group, Delta group. Delta. Delta, you're in this dome over here with Ronnie to begin with. And Gamma here, you're in this dome with Joe, and don't put off by the fact that he said I stole all his material. He's got heaps more and he's asking lots of questions.
If you've got a spare 30 odd pounds, then I've got the perfect spot for one of these in the backyard. I'll even give you visiting grounds. How's that?
Generous.
I thought so. Okay, when you come up to the telescope, the eyepiece is just around here. Don't touch the eyepiece or the telescope. All of the telescopes are quite sensitive to vibration, and it doesn't matter how steady you think you are, you're not. So you'll shake it and you won't see the object as clearly as you might think. Now, just to contradict myself, there is a little rubber ring here around the glass of the eyepiece. Get close enough to the eyepiece that you can just gently feel that little rubber ring on your forehead and or your cheek, and your eye will be the right distance from the glass. Is anybody wearing glasses? Yep. Try looking through the telescope without your glasses first.
Yep.
Yeah, some people's eyes are such that you have to keep them on, but try without them first. If you have to keep your glasses on, you may not quite get close enough to the glass of the eyepiece, so you may not get quite as good a view. Now, we've got some people that will probably need this. So I'll bring this around now. We'll just readjust that. Now, what I like to do is I'll start at one end, so we start from this end, and we'll get everyone to move around to the right as you come through. So who would like to go first? Would you like to go first? No? I bet your brother does.
Hold him back.
Okay, now before you get too carried away there, I'll show you what you're looking at. We've got 3 planets in the sky tonight. We have Jupiter, which is that bright one just there. We have Saturn just there. And around about there is Mars. And you'll get to see all of those. This telescope is currently looking at Jupiter. So you'll see the disk of Jupiter. You will see a couple of dark cloud bands across Jupiter. Those are called the equatorial belts. In between those two is the equator of Jupiter. But you will also see the 4 main moons of Jupiter, what are known as the Galilean moons.
Can you see them now?
From the top, we've got Ganymede, Io, Europa, and then on the other side we have Callisto. So those are the 4 bright points that are more or less in a straight line either side of Jupiter. Does anybody know how many moons Jupiter has? At last count? Did I hear someone suggesting 8?
Yeah, I think so.
Way more.
More than that.
Way more.
21
Oh, nearly.
The visible one.
You're very close. Slightly wrong.
86.
It is in fact 79. 79 moons Jupiter has. And I do say at last count, because they do find new ones from time to time. Okay, let's let someone else have a go, shall we? And come around to the right, come around this side.
Head that way.
Once you're done, head around this way. Yep. Now, you all know that Jupiter's the biggest planet, don't you? Do you know how much bigger than the Earth it is?
A lot.
It's a little vague. Let's try and tie it down a bit better.
Technicalities.
Oh, and by the way, there is a test tonight at the end of the night.
Yep.
You've got to tell us which is your favourite planet.
There you go. You're just looking.
And it should be just about right. Now, if when you're looking through the telescope, it doesn't look quite sharp and focused, let us know, because we can adjust that. The telescope is focused for my tired old eyes, which are not the same as everybody else's. The person that I had, the trainee that I had in here with me last night, his eyes are completely different to mine. So when it was focused for me, it was quite blurred for him, and vice versa. So, the Earth is just under 13,000 kilometres in diameter. Sounds moderately large, doesn't it? Jupiter is about 145,000 kilometres in diameter. It is much bigger.
Like I said.
Yes. But now we know the scale. Yes. Just to give you a slightly different perspective on how much bigger Jupiter is, if we could hollow out Jupiter and we'd had a little hole at the top and we could drop in Earths, you could drop in about 1,100 Earths into Jupiter.
1100.
It's just a touch bigger.
The focus is probably a little bit off.
Okay, focus is this silver knob just here.
Of course.
Which just happens to be in a very convenient spot tonight for Jupiter. When you come back later for your second object, it will be in a less convenient spot. Unfortunately.
How are you going?
Yeah, we've still got about half of them to go. Yeah, probably won't have them this night, but here's your little other interesting little fact about Jupiter, in amongst many. I'll ask you this question. Which planet has the shortest day? Shortest day. We know the Earth is about... There are 4 planets that have a shorter day than the Earth. Which one do you think has the shortest day? Venus is special, but in a different way. I'll tell you about Venus in a minute.
Shortest day.
Shortest day. I'll give you a clue. No, Mercury is also much longer than the Earth. I'll give you a clue. You're looking at it.
Jupiter.
It's actually Jupiter. Jupiter has a day that is about 9 hours 50 minutes.
9 hours 50 minutes.
actually spins much, much faster than the Earth. At the equator on the Earth is spinning at around 1600 kilometres per hour, which is pretty quick. If you were standing at the equator on the Earth, you wouldn't notice, because you're also doing 1600 kilometres per hour, so your net speed compared to that is zero, so you don't feel that movement. At the equator on Jupiter, Jupiter is spinning at 77,000 kilometres per hour. If the Earth was spinning as fast as Jupiter, there would be no people on the Earth, because we would all get thrown out into space. 77,000 kilometres per hour is faster than the Earth's escape velocity, which is the velocity that's required for an object to leave the Earth's gravitational field. So just be thankful that the Earth is a bit more sedate than Jupiter. Otherwise you need to take a very long, very deep breath.
Biggest and fastest.
So does that mean that with a super fast spinning rate and the extra gravity, would that be felt less because of the escape velocity potential, or the rotational
I'm not quite sure what you're asking there.
Yeah, that's a bit of, I know what I'm asking, but
Rephrase it so that
so
hopefully
if you're on the equator going really fast on Jupiter,
Yep.
and obviously Jupiter's got much stronger gravity because it's much
Correct.
larger.
Has
But then
everyone
with
had a
the-
look?
With the
Feel free to come and have another look if you wish.
would the felt effect of the gravity be less on the equator of Jupiter
No, it
because
would,
you're spinning quite fast?
no,
closer to
you
the-
wouldn't feel that.
Yeah.
You wouldn't feel
Same as on the Earth.
Yep.
Because you would be spinning at the same speed.
Yep.
So your net speed compared to the planet is zero.
Correct.
Right? What you would feel is rather weighty,
Yep.
because Jupiter's gravity is about 2.5 times that of the Earth. So if you weighed 100 kilos here on Jupiter, you would be about 250 kilos. So you'd probably be lucky to stand up.
Probably.
But if you actually got to Jupiter, it really wouldn't make any difference, because you couldn't stand up on Jupiter anyway. Because what you're looking at when you're looking at Jupiter is just the top of its atmosphere. And Jupiter has clouds of methane, ammonia, and other similarly really nice gases, highly poisonous, that go down about, we think, around 50,000 kilometres. So if Jupiter has a surface, and we don't actually know that because nothing we've sent into the atmosphere of Jupiter has survived anywhere near that distance, so we don't actually know. If it has a solid surface, it's at least 50,000 kilometres down. So we simply don't know.
Yep.
So you're saying Jupiter just could be a cloud?
Much of it is, in
Yeah,
fact.
just a hard cloud.
Yeah. They think there's a semi-solid hydrogen core,
Okay.
as I said, about 50,000 kilometres down. Right?
Oh,
But
yeah.
that atmosphere is so thick. Like, if we found where that surface of the solid part of Jupiter is, and we stacked Earths on top of each other, we could actually stack 3 Earths on top of each other and still have thousands of kilometres of atmosphere above that before we reach the visible surface of Jupiter.
Okay,
It's a lot bigger than the Earth. And as Matt said before, Jupiter is one of the 4 planets that has rings. But the rings of Jupiter, Uranus and Neptune are very, very faint. Very faint indeed. Now, when I was asking you about the planet with the shortest day, someone suggested Venus. Well, Venus is actually the opposite end of the scale. Venus is special because Venus has a day that is longer than its year. Have a think about that for a second. Right? It rotates on its axis so slowly that it takes longer to do that than it does to do a whole trip around the sun. It revolves around the Sun in about 225 days, but it rotates on its axis in about 243 days. And the other little claim to fame that it's got is that it's actually rotating backwards. It's going the wrong way. And there are two planets that do that. Uranus does the same. Uranus and Venus both rotate backwards. Uranus is a bit special because Uranus is actually like a ball rolling on its side because its axis is tilted so that it's actually on its side, which I find a bit bizarre. They think that both Uranus and Venus fairly early on in their lives were hit by something massive that basically knocked them over in the case of Uranus and got it spinning in the opposite direction and got Venus spinning around in the opposite direction as well. Anybody else want to come up and have another look? Feel free. And of course, as you're going around the various domes, don't forget to ask all those questions we know you've got. If you're really lucky, we'll know the answers. And if not, I reserve the right to be creative. Or as one of our other hosts likes to say, we'll just make up something that sounds sciencey and cool.
It's all confident enough. You'll get there.
We haven't been caught out yet. It is.
Why did that thing move just then?
Because I moved it. It's just to trick you. See, this is the odd one out, this dome. All the other domes is just a bit at the top that moves. But in this dome, the whole building moves. Which is a bit annoying for me when we come up when it's still light, because seeing this building move is enough to set off my vertigo. But when it's a bit later in the evening like this, I can't actually see it moving, so I'm okay. I don't get dizzy and fall over. It sounds like you're about to get moved on.
Yes. Can I take your group, please, Joe?
You can.
Come with me, folks. Grab the camera group.
See you again in a little while. Look forward to it for another object.
What were you guys having a look at just now? Oh, excellent. You're going to see something even better. Okay, is that everyone? Yep. Okay, my name is Morris, and this is Rosa. And Rosa, do you want to start proceedings?
If you like.
Yeah.
Sure, no worries.
Just do the whole thing with the...
Alright, cool guys. So just a couple of things. We're going to show where the eyepiece is. Obviously to get to the eyepiece, you're going to have to go up the ladder. When you've got the ladder, face the ladder, grab the railings, and just make your way up. Once you're up here, this is the eyepiece here. You're just going to look into it and have a big gasp. It's amazing when you see it, alright? However, if you've got glasses, you may want to remove your glasses first and have a bit of a look through there. Sometimes when I've got my glasses, I take them off and I can actually maybe sometimes see a little bit better. That's totally up to you. Have a go at that. When you're coming down, just grab the reins and come down. So, guess what? You're first.
Who would have thought?
Yeah. You can see you're doing so well. A little bit more. You're almost there. That's it. Yeah, that's it.
That would be Saturn.
Very, very good. So, describe what you're seeing to everybody here.
A planet with, like, the planets are almost bigger than the planet itself.
It's amazing, isn't it? So yeah, what you're actually looking through, what you actually see is the actual rings of Saturn. Do you see anything else? Any star-like
Yeah, I see like tiny dots.
little specks? Yeah, beautiful. So you're seeing the moons as well?
I see 3.
Beautiful. Alright, so your vision is actually quite good. This is a planetary test. So you will find something looking through the eyepiece, you may think you're seeing certain things, and that's fine. With what you'll see tonight is Saturn. Now, if you don't know where Saturn is, you guys know where Jupiter was? Was that shown to you? Yeah. So if we look up now, just lost my place here because I can't see. If we're looking up at Jupiter, you'll see a little star looking thing next to it, about 1 o'clock. That's roughly where it is. So it's just, it's over there. Let's go over there. So anyway, so it's over there. And as it's making its way through the sky, it's obviously going to start to set. And eventually we're not going to be able to see Saturn because it's going to be travelling through and we'll have other things to look at. So for now, when you're looking at Saturn, the most amazing thing you want to remember is have a good look at those rings because they will be disappearing soon. For what is it, 200 million years?
Let's say 50 million years.
So probably not in our lifetime.
Yeah.
Not in our lifetime. So that's,
Well, think that's
you never know.
not too sure.
That's it. So when you look at those rings, yeah, that's an amazing thing. So take the most of the time to check those rings out. And if you actually tune into the rings, you may even see a little gap between the actual rings. That's the Cassini division. That is obviously one of the highlights, and you should be able to see that as well. When you're looking at those rings, we consider because they're quite reflective because it's actually made up of ice. So that's why we can see it so well. Now it spans across about 282,000 kilometres. That's all the little rocks that are around there, from small, small rocks to like big, small house. They do vary in sizes, but they're very, very long. But they're very thin in thickness. They're actually only 10 metres wide. If that makes sense. So it's literally almost the size of a house. Yeah. So that's, you can easily shrink that. So I found that really amazing. When you're looking at those moons, does anybody know how many moons Saturn actually has? Would you like to have a guess? Okay, I reckon more than 50, less than 50. Very good guess. It's a pretty big planet, so it will have a lot more than what we think. It actually has 89 moons to this day. 89, that's a big, big number. Now, some of those are not all, like moons where we think of moons. They could sometimes just be like, pretty big, oversized rocks. But they'll also be like asteroids that have been captured and been brought in. Like Jupiter, Jupiter's got a little faint ring as well. You never see it, but those rings are actually made up of rock, whereas Saturn is made up of ice. Any questions about Saturn? Anything else people would like to know? So the other thing about Saturn as well, compared to the other planets, Jupiter and Saturn are gas giants. Uranus and Neptune are ice giants because they're a bit further out. Now with Saturn, it's actually the least densest planet in our solar system. So that actually means that if you were to find a bathtub big enough of water and you placed Saturn in it, you would probably find it would definitely float. That's how light is. Everything else would literally sink. So that's actually the density wise, it's very light. And you probably wouldn't find that much water in our whole solar system. It still wouldn't be enough to fill it anyway, for Saturn. Saturn is also known for Titan. Titan is it's the second largest moon in our solar system. And Titan, the thing I like about Titan is that Huygens mission many years ago actually went and actually landed a craft there. So we've landed on Mars, and we're going back to Mars. We've got the Artemis project, which will be going back to the moon. But there's another project called the Dragonfly mission, and that is actually going to Titan and actually landing there again. Yeah, Titan I think is pretty cool. Enceladus, I don't know, has anybody heard of Enceladus at all? It's one of its other moons. This moon is actually quite cool because there's also showing forms of ice and water underneath its crust. Enceladus is pretty cool, and so is, if you've heard of Europa as well, which is one of Jupiter's moons. So between Titan, Enceladus, and Europa, they are the three top moons we want to go to because they will probably harbour life. We're talking like aliens, we're talking more like microscopic organisms, but it's a start. Where else? So yeah, Saturn moves around the ecliptic plane along with all the other planets. So they come out all in one section. So when you look at the planet, if you're going to the planet, you're going to orbit around. It's always doing that, you know what I mean? And with stars, before you often will see that if you look up high, they twinkle less. So when they go lower, you'll see they twinkle heaps. You're going to go, oh, look at that star there, it's really twinkling. That's because being lower is going through more atmosphere. And that's why they twinkle so much. And that's why we're going to see these objects. So, you know, even if you don't have a telescope, all you need is a pair of binoculars. I've got a pair of binoculars at the back there, and you'd be surprised what you can actually see in dark skies. We are quite lucky here. We can even see the light pollution already coming over the Kalamunda area. But if you were to go to like, other places that are countryside, you'd be amazed what you can easily see.
Do you want another look?
Quick, the rings are disappearing.
Oh, God, 50 million years.
That's it.
Brush.
That's it.
I used to look up a couple of years ago.
Yes. Did it look like white milk being spilled across the sky?
I slept outside a lot in the swag and it's magnificent.
Yeah, that's right. So you'll see some of these are naked eye objects, but once you've got your telescope, you will, with a binocular, you can actually see Jupiter and some of its moons anyway. That's how, and that's with Galileo, when he discovered Saturn back in 1610, he actually thought, because his telescope was more of a long refracted type telescope, which didn't let much light in, he would actually look at Saturn thinking, what are those ear-looking things? So he described the planet to have ears, because his optical tubes were like, you know, not very good, but he had lots of no light pollution, so he was getting pretty good money for his buck, you know. And then later, I think it was Higgins that actually, I think it was 1655, he verified that there were actual rings. So everything is changing, you know. What you're looking at now is past. How many, do you know how far, I always forget because all the numbers just start to blend in after a while.
Oh, Saturn is away?
Yeah.
1.5 light hours.
That's right. So that's how long it's taken for that light to reach our eyes tonight.
So things could have changed.
Yeah, absolutely.
Since
So
we've looked at it.
absolutely. Yeah. So we'll see more with Saturn. We'll see things more clearly because it's much closer. When you're talking about Beetlejuice, that could have already gone supernova. We're still waiting for the light to reach us. With the sun, for example, that takes 8 minutes for that sun to hit our eyes every day. I hope you're not looking at it. But do you know it actually takes 4 years from the centre when the photons are actually being kind of from the hydrogen, it's all making its way through the light. It's actually taking 40 years to get to the surface, but only 8 minutes to reach you. It's amazing that. So I find that really amazing. Maura, is there anything else you want to add? Any more questions about anything else or anything about the universe? Anything at all? Anything that's been boggling you?
Does anyone know why we've got 7 days of the week?
There you go.
Well, the reason is, and we're going to blame the Babylonians for this. Way back in the day, I was very impressed with the moving because they knew where heaven was. It wasn't an abstract thing. Heaven was right there, and that all the gods were up there in heaven. So they were really interested in and impressed by the stuff that was moving against the backdrop of stars, which was the sun, the moon, and the 5 visible planets. So that's where we've got the 7 days. They named each day after one of those objects, one of those gods. And so it's appropriate that on Saturday we are looking at Saturn, because this is Saturn's day. So Moon Day is Monday, Sun's Day is Sunday, and then we've got then the German gods muscled in, because we speak an Anglo-Saxon language. So Freya is Friday. You've all heard of Thor. Thor's day is Thursday. Woden is Wednesday. And I need to Google Tuesday.
But when you say Google's not too bad, I really want to check things out too, because if you want to know whether what moons are actually around and where are they situated, you can Google apps and then tell where the moons are, so you can get apps to as well. You can see where those moons are, so that's when you're looking up for them.
So any questions? We'll try and answer as best we can. If we don't know the answer, we'll just make up something that sounds plausible.
Yeah. We'll do a disaster. So is this the first time you guys have seen Saturn? Yes. You've seen it before? Oh, wonderful. What were your thoughts when you first saw it? So far away, and yet you're looking at it, and it's right there in front of you. It's amazing. Have you heard about the hexagon on the top of Saturn? Anybody heard about that? So I think the Cassini mission as well.
Yeah.
Cassini went out for about 20 years and started to do a bit of flybys around it. They captured amazing footages, and they've got a vortex on the bottom, on the south, and also I think on the top. But this particular, which is like 1,000-kilometre wind, we're talking hurricanes, just like Jupiter, just not as intense. And it literally it's actually started to be created into a form of a hexagon. Now this hexagon is so big that it almost fits 6 Earths. So the diameter is the same as the Earth. That's pretty amazing, that's pretty big.
It's just amazing to see a weather system that's in that shape.
Yes, a weather system.
That's bizarre.
So Jupiter's got the little red spot and Saturn's got the hexagon. That's worth looking at as well. And the colours change. Something to do, I think, with the certain I think it's helium or one there's ammonia.
Oh, you're already here.
Yeah. When you're ready, we can come out to the centre.
There you go.
Gather round, folks. I'm just going to talk you through a little bit while they move the telescope to the next round of targets. For a couple of them, well, for 3 of them, it's not too bad because they've got computers in their telescopes. So even though they'll make out like it's a big mystery, they just have to punch in some numbers and it'll be fine. For Lexi, working with the 110-year-old Calver telescope, however, there is no computer, and if we're quiet for a bit, we may actually hear her cursing as she switches to the next target. So, while they're doing that, we're going to have a little bit of a look at the night sky with our eyes instead of with telescopes, because there's a lot of astronomy you can do without the use of a telescope. So, we've already seen the planets. I've already pointed out the planets to you. I'm just orientating myself a little bit. We have the Milky Way, which is our galaxy, and I'm just trying to orientate myself a whole lot better, but the Milky Way is going over this way. Our Milky Way Galaxy, our home galaxy, is a nice disc shape with spiral arms. It's like a flat disc with some spiral arms. We're in one of the spiral arms. We're about 2/3 of the way out to the edge. The Milky Way Galaxy is about an average sized galaxy. has about 100,000 light years to get from one side to the other. So if you're on one side, it would take about 100,000 years for the light to get to the other side. We're about 2/3 of the way out to the edge. We're about 16,000 light years from the edge. There is about 200 billion stars in the Milky Way. So 200 billion suns like ours. Well, they're not all like ours, but roughly sort of the same thing, stars. The Milky Way is, as I said, an average-sized galaxy. We think, we haven't counted, but we think there's about another 100 billion galaxies out there. So, if you take away one fact from tonight, it's not really a fact, but it's kind of a thing, space is really, really big. And there's a lot of space between things. So, the other thing you should take away from tonight is when I tell you things like numbers, like that there's 200 billion stars, we're guessing. We haven't counted the 200 billion stars. We can't see most of them. If you look up at the night sky tonight, you're probably going to be able to see in the order of hundreds of stars. On a perfect night, you'll be able to see of the order of thousands of stars. Just the ones that are relatively close to us and relatively bright. So, some things we can look up at in the night sky. We've got some nice stars up there. Someone earlier was asking me about the Pleiades. You can see the Pleiades. And I said that they weren't up tonight. They are actually just up. They're just above the trees over here. That's the Pleiades. The Seven Sisters. Now there aren't 7 stars there. On a good clear night you can see 13. It is one of the few constellations you can look at where all of the stars are actually together. That is what we call an open cluster of stars. And you're not going to be looking at one of those through the telescope tonight, so it's nice that the Pleiades have come up and given us a bit of something to look at. So there's the Pleiades there. So those are actually stars that are together. They're a little group, what we call an open cluster. There's about 400 stars in that grouping that are clustered together. We call it an open cluster because there's only 400 stars, so there's not as much mass, so there's not as much gravity holding them together. They're going to drift apart. This is a nursery for stars. Our sun was born into a group like that, but the stars have long since drifted away. So these are quite young stars in the Pleiades. It's called the Seven Sisters because someone looked up at it one night and could only count 7 stars. On a good night you can see 13 if your eyesight's really good, but there is actually 400 of them. The Japanese call this Subaru, hence the Subaru car badge, which actually has only 6 stars on it. Lots of variability about that. So that's one of the few constellations where you can see that the stars are actually together. Now let's click on some other constellations, and there's Orion coming up here that sits in the trees. There's Orion's belt and Orion's sword, and that's Orion's foot. Orion's upside down because he was named in the northern hemisphere. That's his foot there, his sword, otherwise known as the frying pan, the saucepan, the shopping trolley. That's also a rare constellation in that it kind of looks like what they say it looks like. I was talking to Jeff, one of the other volunteers, a little while ago, and later on tonight he's going to be looking at the constellation of Dorado for a different purpose, and that's roughly up here somewhere. Dorado is a dolphin fish. Now, if you can see a dolphin fish up there, congratulations. But I've got a better one for you. Up around here, somewhere in this area, there is a toucan, apparently. A toucan. Yep. I've been doing this for about 14 years. Did astronomy for a bit before that as well. Never seen a toucan up there. My thinking is that maybe somewhere along the line, some astronomers in time, a couple hundred years ago, they were a long way from home because this is a southern hemisphere item. It's not something you can necessarily see in the northern hemisphere. So they were a long way from home. They were looking up. It was cold. They took some drinks to fortify themselves, and they saw a toucan. Maybe I've tested it. No toucan. But anyway, these constellations even though they look like they're groups of stars to us, so if we look over back at Orion here, even though we've drawn a link between all of those stars aren't together. Some of them are much closer, some of them are much further away. If we were in another part of the Milky Way Galaxy, we wouldn't actually see that shape of Orion. So most of the constellations don't actually have any sort of astrophysical meaning to them whatsoever. They're not generally clustered together. It's just that they look like they are. The Pleiades, though, is an example of a group that actually is together. They're kind of hanging out together. So, in terms of distances, we've looked relatively close so far. We've looked at Saturn and we've looked at Jupiter. They're like right next door to us. We're going to go a little bit further out now through the telescopes. We're going to look at something in this, we're going to look at a couple of things in this area of the night sky. Now, there's a little bit of cloud around at the moment, and some of you might be able to see a little wispy cloud there and a little wispy cloud there. Those aren't clouds. Those are galaxies. That one there is the large Magellanic Cloud, and that one there is the small Magellanic Cloud. Now you're going to have to trust me on this, that I'm not just showing you regular clouds, because I could be, but I'm not. Almost certainly I'm not. So the large Magellanic Cloud and the small Magellanic Cloud are satellite galaxies of our Milky Way. They're much smaller than our Milky Way, and so they're kind of orbiting around our Milky Way. At some point in time, our Milky Way will cannibalise them, and they'll become part of the Milky Way. The good news is that if you think that the Milky Way is being a bit harsh on them, they're currently heading for a collision with something called the Andromeda Galaxy, which is bigger than us, and they're going to cannibalise us as well. Again, our sun's going to completely consume the planet Earth in a couple of billion years. Before that's a problem for us, so don't stress. So, large Magellanic Cloud there, small Magellanic Cloud there. Small Magellanic Cloud is, large Magellanic Cloud about 160,000 light years away. So you're going to be looking at something there in that area, which is 160,000 light years away. So the light has taken 160,000 years to get here. That seems like a long time to a human being, but in a star's life, that's nothing. That's a blink in an eye. There's a great star story that we can look at. Unfortunately, it's not quite up yet. But in Orion, that's his foot, that's Rigel. Down here, in the tree somewhere, is Beetlejuice. Beetlejuice is what we call a red supergiant. It's a big star. The bigger a star is, the quicker it gets through its life. And the reason it's red is it's cooling down. If you look at a candle flame at home, hottest part of a candle flame, white blue bit, coolest part of a candle flame is the reddish orangey bit. That's cooling down. Now, for the purposes of health and safety, I'm obliged to tell you, particularly children and also blokes, every part of a candle flame is stupidly hot. And you shouldn't stick your finger in there and end up in hospital telling them that some guy at the observatory said that part of it was cool. It's not. It's all hot. It's just cooler. So, Betelgeuse is cooling down. It's getting close to the end of its life. What that means in human terms is that at the start of the year, we noticed that Betelgeuse was dimming all of a sudden. Now, Betelgeuse gets dim and then it gets bright and gets dim on a regular cycle, but it was getting much dimmer than we had thought it should do. And so astronomers got really excited and we started jumping up and down saying, it's going to explode any day now. And the media picked up on this and they went, wow, it's going to explode any day now. And it's going to be spectacular when it explodes. It's going to be a supernova explosion. It's going to be bright enough that it's going to be as bright as our full moon in our night sky for about 30 days. You're going to be able to see it during the daytime. And that is super cool. So when we say it's going to explode any day now, wow, that's going to be awesome. Except for any day now in the life of a star means sometime in the next 100,000 years. With the emphasis on the 100,000 years. So, as it turns out, Betelgeuse got brighter suddenly and we don't even think 100,000 years now. So, whenever an astronomer says any day now, that means a long time in the future. 100,000 years in a star's lifetime is not very much. Okay.
But it's a probability.
It's a probability, yeah. It's likely that it's going to take a while before it explodes.
So there's a possibility it already has exploded.
Very unlikely, because Beetlejuice is only about. I'm going to guess this for a minute. Beetlejuice is only about 700 light years away. So the light's taken 700 years to get here. There's a slim possibility it's already exploded. Like, it could have exploded 200 years ago. You won't know about it for another 100 years. But 700 years in a star's life is almost nothing. So it's unlikely that it's exploded. So when you're looking at something even 160,000 light years away up here, and you think maybe those stars aren't still there, yeah, they're still there. Almost certainly still there. In a galaxy the size of the Milky Way, average sized galaxy, 200 billion stars, there is a supernova every 100 years. The Large Magellanic Cloud is much smaller. It's not due for another supernova for a while. Not a whole lot, it just means that the stars get kind of pulled into the same structure, etc. They don't collide. We talk about the galaxy colliding, but the actual stars don't collide. So we'd still be okay. Alright, I'm going to find out where our telescope operators are at. So, Harlow, how are we going there? That's excellent.
16's ready to go.
16's ready to go. How's the Calva? Good? 30-inch, Ronnie. That sounds about as positive as you would hope. Right. Okay, I'll keep talking for a little minute while Ronnie works that stuff out. Okay. So, what you're going to look at next, you're going to look at a nebula. Yeah. You ready? Oh, excellent. All right. So what we're going to do is we're going to get you to go back to the telescope you first started in. So, Alpha group, you're going to go into this telescope here. Beta group, over here. Delta, over here. And Gamma, over here. Please.
He's a bit quick, I don't get to have my proper pit stop. Okay, eyepiece now is around this side. Now when you come up to the telescope this time you need to be a little bit careful because we've got a telescope piggybacking here and there's a chance that you might bump your head, so hopefully you can avoid that. I tend to bump my head anyway, even though I know it's there. And we've got the finder scope up there, but you should be okay. Now, let's bring the ladder back around, because I think we've got some people who might need it. Let's bring that around about there for those that need it. Who's going first? Are we starting from here, or we've got... Where are we starting?
Number 1 now, yeah.
Yep, you can go first. Just in there. Okay, what we're looking at here is a star-forming nebula called the Tarantula. So your challenge is, can you see a big fat hairy spider through the telescope?
I see a scorpion.
Yeah, this is what I was complaining to Matt about before at the start of the night, giving away all our trade secrets. This object is so far away, it's actually in another galaxy. This object is in the Large Magellanic Cloud. It's 165,000 light years away. So you are looking at something not as it is tonight, but as it was 165,000 years ago. You are looking into the past, a long way into the past. Because the light that your eyes are seeing tonight on the Tarantula Nebula has taken 165,000 years to get to you. Yep. So what you're looking at, as I said, is a star-forming nebula. It's basically a huge cloud of hydrogen gas that is actively forming stars. And we'll get you to let somebody else have a look now. Otherwise you could be stuck there forever, I think. So it's a huge cloud of hydrogen gas actively forming stars. There is a cluster of very large stars in the middle of it, which is causing the nebula to glow, which is why we can actually see it. Because the nebula itself is just hydrogen gas, and hydrogen gas on its own, you can't see it, it doesn't glow. But the very hot, young, bright stars in the middle are generating a lot of light in ultraviolet. So, let's go back a bit, that should be about right, just in there. And it's the ultraviolet light of those hot young stars that are ionising the hydrogen gas, a bit like a neon tube, and causing the gas to glow. Do you recall whether you looked at the photos of the Eta Carina Nebula in the main building before we came up?
Yeah.
You saw that distinctive bright pink colour? This nebula is also the same colour. And that distinctive bright pink is the colour of ionised hydrogen. So when you see astronomical photos, you will often see lots of little pink patches in them. And this is what you're looking at, something like this. This one is really special. It's actually the biggest star-forming nebula that we know of in the universe. All of the stars you can see in the night sky, or even in the daytime, like our sun, were all born in a cloud of hydrogen gas like this. Most of the time, those clusters of stars that are formed within the nebula are relatively small, anywhere from maybe 500 stars to a few hundred. The bigger nebulas form maybe 2,000 to 2,500 stars. Well, this one is so big, it forms something at its centre, causing to light up, there's a cluster of a couple of stars. Some of those stars are actually impossible. And by that, I mean that those stars are so big that they should be tearing themselves apart. They're producing so much energy that they should not be able to exist. They should be literally tearing themselves apart. But that just goes to show where there's a lot more we need to learn, because they're there, they exist. There are a couple of dozen stars in there that are over 200 times the mass of our sun, whereas they shouldn't be any more than about 150. But the biggest of them is over 200 times as massive as our sun. That particular star is the brightest one we know of in the universe. It's shining roughly 9 million times brighter than our sun. Imagine what SPF factor you'd need to go sunbathing underneath that. Actually, don't worry, you wouldn't matter. You wouldn't need any, because you would be instantly vaporised. Quite literally. If that star was where our sun is, there would be no us. There would in fact be no solar system, because that star is pumping out so much energy that it would fly material around it that could have formed planets and life. So there is no way that planets can form. Now those big stars, and there are hundreds of them, they're all going to explode as supernovas when their very, very short lifespan expires. Matt told you earlier, the bigger star, the shorter the lifespan. These particular ones, we're actually lucky to be seeing them because they're only going to live for maybe 2 million years. They are that big. Doesn't sound very long, does it? But when you think our sun's been going pretty much constantly for about 4.5 billion years, and it's got about that long to go again before it expands to a red giant and swallows up and vaporises Mercury and Venus, and possibly the Earth as well, and then slowly fade away to a white dwarf. These things won't even last 1/10% of that time. They live a very short, very violent life, then die as a supernova explosion, which is the most violent explosion in the universe. When that happens, they will be the brightest stars in the sky for about a month, maybe 2 months, and that's from 165,000 light years away. They will be very clearly visible to the naked eye. Part of the reason why we know that is that one of their neighbours actually did exactly that in 1987. If everyone's had a look, feel free to come back and have another look.
How you going, Joe?
Everyone's had a look.
Okay.
Back in 1987, one of the stars at the edge of the Tarantula Nebula actually exploded as a supernova, and it was a reasonably bright naked eye star from 165,000 light years away.
So you can see it.
It was very clearly visible to the naked eye
1987.
for about 2 months.
1987.
Because I was forever going out at night pointing it
Supernova
out to friends and
1987.
family.
Nag-explode
Yeah, showing them where it was. And that wasn't even one of the really big ones. That one was about 80 times the mass of our Sun. It was nowhere near the 200 solar mass plus monsters that are in there. But that was still a fairly bright star for a month or two. Have you all heard about the star Beetlejuice?
Yeah.
He's been talking it outside there,
Yeah, that's going to be coming up in the east, probably around about the moment we're beginning. It's a little bit low at the moment. That's the closest star to us that is going to go up as a supernova. When that explodes, we're going to get one heck of a light show. That's going to be bigger than the sun. It will be nearly as bright as the full moon. That's how bright it will be.
but we won't be around.
Unlikely, because unfortunately, although we know it's going to go supernova because it's big enough, they're not predictable. We don't know how long it's going to take, and there is no way we can predict that. We will get maybe 2 or 3 hours notice that it has exploded. Because just before a massive star explodes as a supernova, it starts generating masses of neutrinos, many more than it normally does. And there are quite a few neutrino observatories around the world. They're deep underground, and they've got dense fluids, and they're in big caverns, and all around the edges of those, they've got thousands and thousands of very sensitive detectors. And when a neutrino hits another particle, it gives off a particular frequency of light. And those detectors around the edges of those caverns, that's all they're looking for. They're looking for those little bits of light. And on average, they might see 5 or 6 a day, if that. Even though, at the moment, every second, there are trillions of neutrinos passing through your body. Every second. But they interact with other matter so rarely that you would only detect maybe 5 or 6 per day. But when a supernova goes up, that detection rate will be hundreds and hundreds of times more. So they'll pick up, all of these neutrino detectors will suddenly pick up a massive spike in neutrinos, and they'll know that something's just exploded. But there's no way of detecting which direction they're coming from. So we don't know where to point the telescopes at, which is a damn nuisance. Because the holy grail of supernova research is actually to find one as it's brightening, as the explosion has just started. And that is so rare. I think it's only been observed once or twice in all of the supernova explosions we've detected. So that's what astronomers are really hoping for, that at some stage they'll actually find one and be able to watch it brighten rather than see it as the bright object. It'll happen one day. Yep. Now I'm sure we haven't filled your brains up just yet, so are there questions you may have? Anyone out there? Otherwise, you get to listen to me waffle on all night. Okay, when you go, you say, we're going to have to
Thank you.
welcome.
Hindi tayo pupunta doon?
Dito pala tayo talaga namatay yung Uranus.
Could you actually see the spider or? Oh, that's good enough. That's good enough.
It's on the same plane.
And legs.
Alright, cool. So, you guys already know about the ladder and where the eyepiece is, yep? So you have your number one already. So guess what your job is to do? Describe to everyone what you're seeing. That's it. It's your job now. Can you see the eyepiece there? That's it, thanks.
I see like, it looks like hundreds of thousands of stars.
You're on the right track, absolutely. So what you're looking at
In the
is...
middle is a lot brighter than...
That's right. So it's very bright in the centre and scattered out a little bit. Perfect, that's excellent. So what we're looking at here tonight is a 47 Tucana, which is basically a globular cluster. We're talking millions of stars, gravitationally bound together, and they are absolutely beautiful to watch. This is actually one of my favourite objects. It's the second largest globular cluster compared to the biggest, which is Proxima Centauri. You might have heard of that. Yes, that's right, isn't it?
Yeah,
Oh,
yeah.
it's got a blank moment there. It happens a lot, so excuse me. So Proxima Centauri is the biggest, but I find this one just a little bit more visually stimulating. It's just amazing. You can describe a globular cluster as if someone has just dumped a big salt patch on a black tablecloth. You know, it contrasts really nicely. Or maybe a fuzzy cotton wool or bees around a hive. And that's how you recognise a globular cluster. You can actually see them with binoculars. And this particular globular cluster, you might have heard outside before the host was telling you that there's a small Magellanic cloud and there's the large one. This one's situated in the large one. So it's a bit faint to look at now, but on the telescope it looks amazing. So, globular cluster, it's very, very old. We're talking billions of years old. And you will find that in the centre, like the young lad mentioned before, that it's so bright in the centre because all the stars are much closer. They're almost about a light year apart. So if you were anywhere near this cluster, you'd literally be seeing a bright sky day and night. That's how bright it would be. So They're about a light year apart. A light year is about 10 trillion kilometres, and that's really nothing when it comes to stellar kind of numbers. So it's globular cluster, massive, lots of stars, and they're not really in our Milky Way. The Milky Way is actually a flat spiral disk, but the globulars are kind of like hanging around the halo of the Milky Way. Now there's about 200 of these around our Milky Way, and most of the globular clusters that we know of, most of them do have black holes in the middle. Okay, Amelia definitely has one. Amelia was somehow thought to have been maybe part of a galaxy that was cannibalized by the Milky Way. And that's what galaxies do. They eventually start merging together. But most of the globular clusters have got black holes. Our Milky Way in our centre has also got a black hole. Black holes are amazing things. They actually even devour each other too. And with black holes, nothing escapes it, not even light. So I find that really, really fascinating. So I don't want to Google all that stuff. But when you're looking at the stars, so this particular globular cluster, it has different colours. Some of you see more, some of you see less. So we're looking at an open cluster. An open cluster is something that's a bit more diverse or spread out. So it's kind of like they're not gravitationally bound together, and you only have hundreds of stars. They're really the leftover result of a nebula. So the Tarantula Nebula, for example, after all those gases disappear, it's finished making stars, they are star nurseries. Those leftover stars are star clusters. But globular clusters are very different. They've been formed in a very different way, which we kind of still don't really know or truly understand. So with the open clusters, you'll be able to see more of the colours. And what the colours represent in stars is basically the temperature of the star. Okay? So you have, there's about there's classifications of stars, and there's about 7 of them. Obviously yellow or white, blue are the hottest, and then you get more like a yellow star, classified as a G, and that would be like our sun, which is not going to go supernova, but it's not really that big. And then you've got something like red giants, which are classified as an M-coloured star, which means they're literally at the end of their life. That is something like Beetlejuice, for example. That's pretty much what the globular clusters are. Does anybody have any questions about the globular or anything else?
You mentioned Beetlejuice. Is there another
Probably. I think Beetlejuice is probably the one.
There's quite a few. There's one called Eta Carina that may blow up pretty soon. And there's something that you can probably see in Taurus. You actually see that as you look out. Is Antares? That's Aldebaran.
That's one.
Yeah, Aldebaran.
That's the one.
Yeah. Antares is in Scorpio.
That's correct.
Yeah.
Yes.
Yeah. Antares is another big supergiant that is on the way to possibly being a supernova.
But with the stars, that's the best thing. When the solar system was created, it was just a big bang and then this that. And the big galaxies started to get hotter, denser, and started to gravitationally get closer and started to really get so hot to the point that they actually started to create stars. Then from these stars, eventually, that's when all the heavier elements were created. So you technically on stardust, the iron in our blood, the calcium in our bones, everything. Even this wall is made of the same sort of stuff that I'm made out of, but it's a completely different composition, if that makes sense. But the elements are pretty much still there. It's pretty amazing. And then of course there's main side, that's the and so on and so on. So what the main thing is basically things got created from supernovas. And not all supernova, as we know, our sun won't. Jupiter was supposedly supposed to be a failed star because if it was 8 times bigger, it would then would have had enough gravitational force to kind of start fusing and become a star. But I like to call Jupiter, a successful planet. But yeah, that's just the idea of that. Any other questions on anything else? Anyone want to share anything? Hey, have another look. Yeah. That's the best part. Don't listen to me, have a good look.
Yeah, you're looking at something that's taken 16,000 years for the sunlight to get to you. It's that far away. 16,000 light years away.
Wow.
Gives you an idea just how big our galaxy is.
Amazing.
And our galaxy, as Rosa says, is a bit of a bullet.
I think it was created like 13.8 billion years ago. Our sun is maybe 5 billion years old, and the solar system is maybe 4.5 billion years old. So that's still pretty new.
There's still a lot to learn.
There's still a lot to learn, and there's a lot that's going to change as well. From what I've read as well, is that eventually, when the last black hole evaporates, which that's what they've figured out, and that's what black holes actually do, then they radiate, but they also lose their energy in some sort of way. Basically, the very last stars get made and they die out, so that's where everything is being expanded, everything is eventually going to go to this kind of big freeze. Eventually, when the last black hole evaporates, that they believe that's the end of the universe. And I think they've estimated, from what I've read, about another 13.8 billion years to go. But that's the thing, stars is what creates life. Stars is what creates more. And without stars, everything, just wouldn't be here. So, but it'll be interesting to see what the future will hold. I think the Webb telescope, once it goes up, that'll be really interesting. That's going to use, I think, more radio, what's the word? I forget.
Radio astronomy?
Yeah. And gravitational waves is something that they've been using to detect black holes colliding. So when Galileo came about in 1610, he was using optical instruments, which is what we do, but now we've got different ways of measuring and seeing the universe, and that's how we are advancing. So optical tubes are great, but we're going to see more when you use your gamma rays, X-rays, and that's why having telescopes outside. I think I even heard or even read somewhere that ultimately it'd be great to have a telescope set up on the moon, for example, because then there's no atmosphere, and this is why here, when you see NASA images, they've calibrated different images together, and there'll be different types of imaging with different telescopes from all around the world to produce this one beautiful image, So once you're outside the atmosphere, that's kind of why we have such great images and we can see so far in. I think when Hubble first went up, they somehow had the mirror just like a centimetre or so out. And it was just like they had to go back and fix it. And when they went to fix it, they actually couldn't close once they finished fixing it, they couldn't close the door again. And they somehow eventually got to do that. So nothing goes perfectly smooth in astronomy. But the Artemis project is going to be really cool. Going to the moon, so part of the Mars project as well. So lots of good things going on. Too many.
There is a lot of things.
Sorry?
There is a lot of things.
Yeah, it's like too many to keep up with.
Suddenly what's going on in Mars.
Yeah. And when they're setting things up, they've got to make sure that they know what kind of debris is hanging around the world, because you've got to make sure you're not going to collide with one of them. So everything's really very good. Yeah.
If something happens, that's it, they'll go back to you.
That's right, and there's quite more failures. I think with the Mars, I think it was the Mars project.
Atlas 5 is just having trouble with Mars.
Yeah, but they learn from their mistakes. They're just costly mistakes, that's all. But yeah, any other questions about anything else? Or babble on about something else? Morris, would love to add anything more?
through these telescopes, you have computer images inside the building, wouldn't you? Like, you wouldn't be sitting out here all the time, would you?
You can, we do EAA here at the Perth Observatory. We use the 40-inch dome, which is the other one that you might have already been into. And there we connect the computer to the telescope with a camera. And then the camera will take images that are being downloaded to the actual computer, which then we put onto a big TV screen. And that's actually cameras, you're going to be able to capture colour. Because our eyes, they keep refreshing very quickly. It's more to do. So therefore, you see most things in black and white. You want to see the detail, but you do so when we use the TAA and use computers and laptops, that enhances what we're looking at. When you're using a computer or a camera and you're letting the light build up and build up, starts to collecting and gathering, you will then get those beautiful images. So yes, if you get a telescope, it's worth investing into photography and laptops and that. Definitely. Unless you want to make it in shape.
Yes, right. You're worth more than my house, I reckon.
Yeah, I know. If you make, I think there's a gentleman here in the 30-inch, he was saying how, you know, like he spends a lot of money, you know, it's a passion, it's a hobby, the images he's captured, totally amazing. Like, you can hire at NASA, like, honestly.
Alright, if they're ready in here, I'll take you over to the next dome. Alright, in you go.
Sorry, just readjusting so you can see. So the ladder's in a bit of an awkward
How's
spot.
everyone going?
You good?
Yeah. Cool.
That's my glass. Alrighty, so point out again what we're looking at. So we're looking at Mars. You can probably guess which one it is, looking at where the telescope is pointing. So that's Mars that you'll be looking at. So we can head on up if you like. Grab both sides. Oh yeah, so you're moving. And it should look kind of red, kind of orange, a bit like Mars, but like brighter. I can't hear a reaction. Would you call it Mars?
You call it Mars?
No, like I guess I'm trying to see if it's
What do you
what's being looked at is convincingly Mars, or if it just looks like you know, a star. A star. Does it look like a star or like Mars?
It don't look like a planet with a line on it, but
Yeah. And where do you see that line on it?
right, like kind of right below the middle on a diagonal angle.
Yeah.
Wow, he's seen
Yeah.
really
So
well.
what
Well.
we're looking at is
Yeah, everywhere's gone, he sees everything.
Pointing out the
Good
details.
eyes.
yes, it's great when the first person sees some stuff because you can talk about it. So what that is basically, if you can see a bit of red, first of all, that is basically rust, so it's iron oxide that you're looking at, so that gives it that reddy orange colour. And then if you can see some lines in the middle, usually what that is like a dust storm going on. You're probably not seeing the ridges of like the surface of Mars, but it's probably more likely to be the sort of barrier between a dust storm area and a non-sort of dust storm area. You probably can't see the mountains of Mars through this telescope right now, but the other thing is that it currently does have polar ice caps. So at sort of one end, you should be able to see it looks a bit white. You might be able to see another line kind of demarking that area, possibly. We'll probably have time to have a second look anyway, so we can head up. My first time seeing Mars tonight as well, so you guys have come on a good day, because I think I said earlier that it's the closest that will be to Mars for quite a few years. So,
right.
Yeah, so if you came back in 3 years and looked at it, it wouldn't look as impressive as tonight. So that's also, I think NASA launched something from Florida in July or August.
Yep.
Yeah. So they have to time their missions so that they use the least amount of fuel. And so the cool fact is that we actually sent one of the first probes to Mars before we landed on the moon. So before we walked on the moon in the mid-1960s, we had actually sent probes out there, which I think is pretty cool, because some people still don't think that we landed on the moon. It's so we've actually been all the way out there. Yeah, and one of the first images that we had of the surface of Mars was actually sort of drawn out by hand by people that were receiving the signal. Computers were so slow at that time that literally drawing out bit by bit the data that they were getting was actually faster than waiting for it to churn it through a computer and getting that data, which I think is really cool. So you can actually look up that image, like the first image that NASA got of Mars. They did a really good job of drawing out, like converting the bit of data into an image. So has anyone signed up to be an astronaut? You tried? You thought about it? Yep. Maybe Elon Musk will take you if you plead your case. It sounds like he's planning to just go there at some point. So we can all just hitch a ride with him.
Yung galaxy ba yun? Hindi masyadong maraming stars, hindi ka tulad ng Milky Way.
Andromeda.
Nakakita ng picture? Ano picture? Ha? Okay. Yung Seven Sisters. It's gonna be beautiful. I'm so glad we had learned a lot tonight about universe, about the stars, about the planets. We had a great night indeed. Tagal ilang minutes, hours. It's almost 11 o'clock, so 8:13 na 10:30. So 2.5 hours. Thank you all for watching, guys. Hope you have learned a lot too.